So we're going to be adding vectors together here, and it's going to feel very, very familiar to you. Back when we were doing complex numbers, we had a complex number, 2 plus I, we had another complex number, 1 plus 3i, and I was encouraging you to, after doing it algebraically, draw a picture, and the picture would look something like this. A bunch of arrows added together to make this red arrow here. So we're going to be doing the same sort of thing with vectors, but we're going to be doing it entirely without these numbers here. We're going to be doing it entirely with pictures. So here I have 4 vectors, 4 arrows, and we're going to do some calculations. So u plus v. Okay, and you've got to do things in order here and step through it. All right, the first vector is vector u. Remember, vectors don't have a position. So I can take this vector and I can move it wherever I want. I'm going to take it and I'm going to move it over to here. Okay, there's u, same u's. All right, let's come up with vector v here. Now, vector v is this one here. Now, a lot of people, when it comes to vector addition, use this phrase to help them remember what they're doing. Tip to tail. Okay, so this is the tip and this is the tail. And when you join 2 vectors together, it always has to be tip to tail. 2 tails can't touch, 2 tips can't touch. Okay, so tip, tail, and then we connect V by connecting the tip to the tail. That's vector V. I've picked it up from here and I've moved it over to here. Okay, so if I label everything up now, this is vector U, this is vector V, and in blue we have our answer. This is vector U plus vector V, this blue arrow here. The blue arrow is the most important thing of it, right? Because an arrow plus an arrow is equal to a different arrow. So you have to draw in the resultant arrow. That's called the resultant. It doesn't matter too much. But drawing the arrow is super important, because if you haven't drawn the arrow, you haven't answered the question. Okay, U plus V makes U plus V. Done. We're going to do the other ones faster. Okay, so V plus U. This was U plus V. This is V plus U. So we're going to do it in order. We're going to start with V. V. Okay, that's V. And then we're going to add in U. V plus U. Remember, tip to tail. So there's the tip. We're going to take the tail of our second vector, put it in there. Try to drag it over as best you can, make it the same length. And then our final answer is going to be this vector here. Okay, so that's vector V plus U. And I didn't label vector U, which is here. So V plus U makes V plus U. U plus V makes U plus V. Look at the blue arrow here. Look at the blue arrow here. Same length, same direction. U plus V equals V plus U. It actually doesn't matter what order you multiply vectors in. As long as you're following your tip to tail rule, it doesn't matter what order it's in. U plus V equals V plus U. We say that vector addition is commutative. It doesn't matter what order you do it in, it's commutative. It'll be the same both ways. Okay, so that's the first thing I wanted to show you. I wanted to show you how to draw those arrows. I wanted to show you that U plus V and V plus U is the same. Okay, let's do this. U plus V plus W. You can add 3 numbers together. Why shouldn't you be able to add 3 arrows together? So, U. And then V. Remember, tip to tail. So U and then V. Same length. And then W, straight down. Same length, same length. I've dragged it over, right? Drop and drag. Okay, so if we've got, I won't worry about all the colours, if we've got U plus V plus W, the resultant, the answer, when we add all of these together, is the straight line from the start to the finish. Okay, that line that I've just drawn is equal to u plus v plus w with all the little squiggles. I love it. I love it. This arrow tip to tail thing, it's not something you should really have to remember, because you could think of all of this as a hiker, right? The person walks in this direction, and then they walk in this direction, and then they walk in this direction. They walk, they walk, they walk. Where did they end up? They ended up right here. They could have taken a shortcut and just walked straight along u plus v plus w. So keep in mind, we can add hundreds of vectors. We can add them all up. Something I want you to keep in mind here is that this addition works in 2 dimensions, but it also works in 3 dimensions. These vectors look like they're 2-dimensional, but they're just representations. Maybe they're 3-dimensional. Maybe it's like off this way, and one's going this way, and one's going downwards, and in 3-dimensional space, right? So remember, this addition works whether it's a hiker walking along flat ground or a bird that flies up that way and then turns a corner and flies that way and then turns another corner and flies that way. You can add those 3 vectors together, those 3 3-dimensional vectors together, and figure out what the shortcut would have been for that bird who's turning corners like that. Okay, that is addition of vectors graphically.